Good morning, grade 10s. We're going to be working through the first lesson from the unit Numbers and Exponents. So the first lesson is on page 1 of your workbook, so you can open up to that page. I just want to remind you that anything that I write down, anything that I highlight, I expect you to do the same. So the first thing that we need to know in this unit or in this lesson is what is a factor? What's the definition of a factor? So factors are it's a number that divides into another number exactly, no remainders. Okay, so a number that divides into another number exactly, no remainders. So for example, if I said, okay, well, can you please list the factors of 6? What are all of the numbers that divide into 6 and doesn't leave us any remainders? I always want you to write the number that I give you and then write a colon. And you're always going to start with the number 1 and then give number, right? So 1 is a factor of 6, as is 6. If you took the number 6, we already divided it by 1. If you divide 6 by 2, the answer is 3. So 2 is a factor, as is 3. So then I'm going to write down 2 is a factor and 3 is a factor. Now, I could check 4 and 5, like, or is 4 and 5 divisible by 6? And they are not, right? 6 divided by 4 does not go in evenly, and 6 divided by 5. So 4 and 5 are not factors of 6. There are 4 factors of 6, 1, 2, 3, and 6. Okay, so let's do class example number 1. State the factors of the following. 15. Always write the number 1 and the number I give you. So 1 and 15 are factors of 15. Then you would say, okay, well, what's 15 divided by 2? I'm not going to divide, I mean, I could show you 15 divided by 2. 2 is not a factor of 15. It does not divide in evenly. 15 divided by 3 is 5. So 3 is a factor, and so is 5. Now, I could check the only number between 3 and 5 is 4. You could check on your calculator. 4 does not work. It is not a factor. So these are the factors of 15. 24, 1 and 24. If you divide 24 by 2, the answer is 12. So I'm going to jump up to 2. 24 divided by 2 is 12. So I'm going to put 2 in there and 12 in here. And then the next one, if I divide 24 divided by 3, let's check if 3 is a factor. So 3 is a factor, and so is 8. So 3, 8. So now I've got to check the number after 3 is 4. So 24 divided by 4. So 4 is a factor, and so is 6. The only number I need to check now, and I'll tell you right now, 5 is not a factor. 24 is not divisible by 5. Okay, class example number 2, we're going to work through. I'm going to do a couple of them, and then I'd like you to pause it and do the rest. So A, nice and simple. The factors of 3 are only 1 and 3. And actually, I'll skip to C. The factors of 1, if you divide 1 by 1, you only get 1 as an answer, right? So there's only one factor of 1, and it's 1. B, we could do pretty quickly, and we could probably do that one in our heads. 1 and 10. If you divide 10 by 2, you're going to get 2 and 5. Those are the only factors. What I want you to do is I want you to pause the video, and I want you to write the factors of 7 and the factors of 18. Okay, and then you could unpause the video when you're done, and you could check. Okay, factors of 7 are 1 and 7, and factors of 18 are 1 and 18, 2 and 9, 3 and 6. Nope. Sorry, guys. Let's redo this. 18. Okay, so 18 divided by 1 is 18. 18 divided by 2 is 9. Oh, maybe I did have it right. 18 divided by 3 is 6. And there's no, 4 is not a factor, nor is 5. So those are the factors. And actually, I didn't quite do this question correctly. It said in each case, determine the number of factors. So what I should do, so 3 has 2 factors, and 10 has 1, 2, 3, 4 factors is the answer. Um, C has 1 factor, D has 2 factors, and E has 1, 2, 3, 4, 5, 6 factors. Okay, so that's what factors are. Okay, so definition of factors is the first thing you need to know. Now what we're going to move on to is the definition of a prime versus composite number. So highlight prime and highlight composite. And then the definition of a prime number, it's a whole number which has exactly 2 factors. Okay, so a prime number is a whole number with exactly 2 factors. So for example, 7 is a prime number. The only 2 numbers that divide into 7 are 1 and 7. The number 5 is prime. The only 2 factors or the only 2 numbers that divide into 5 are 1 and 5. Those are prime numbers where they have exactly 2 factors. Okay? If a number is not prime, it is going to be composite. So the definition of composite, it's a whole number which has more than 2 factors. So for example, they give 2 examples of composite numbers, and the 2 examples that they give are 10 and 18. So 10 has 1 and 10. Now, if it only had 1 and 10, it would be prime. But we could divide 10 by 2, and we would get 5. Okay, so 10 is a composite, and these are prime. The number 1, I just want to let you guys know, the number 1 only has 1 factor, right? The only factor of 1 is 1, and that's why they say the number 1 is neither prime nor composite. Okay, so good to know. Okay, I'm going to list the first few prime numbers for you. You have to memorize. I'll tell you how high you have to memorize. So 2, 3, 5, those are primes. 7, 11, 13. 17 is a prime. Remember, these are only divisible by 1 in itself. 19, 23, and 29. I would have, if I were you, I'd memorize up to 23 because we're gonna be doing all these questions right away, and I'm gonna say write your prime factors, and your first few prime factors: 2, 3, 5, 7, 11, 13, 17, 19, 23. Okay. Flip your page. Classify the following numbers as either prime or composite. We'll do this really quickly. 46 is divisible by 1 and 46. I know it's also divisible by 2, so 46 is going to be a composite number. 37, it's only divisible by 1 and 37. Like you could try all the other numbers, divide it by 2, by 3, by 4. 37 is a prime. It's only divisible by exactly 2 factors, the factors of 1 and itself. Number 39, if I divide 39 by 3, I get 3 and 13. So 39 is going to be a composite. 101 and 103, even though I would never ask you, is this prime or composite this high? These are both primes. Okay. Okay. What we're going to do now is the next class example, which is class example number 4. And what does it say? Okay, sorry, class example number 4. State the factors of 12. Okay, so the factors of 12 are what we did on the previous page. 12. Divide 12 by 2, and you get 2x. Divide 12 by 3, and you get 4. Those are the factors of 12. So state the factors of 12. 1, 2, 3, 4, 6, and 12. State the prime factors of 12. So let's go through all of these factors and let's circle which were the prime numbers. So the prime numbers are only divisible by 1 and itself. So number 2 is a prime and 3 is a prime, right? This is a composite, composite, composite. And remember I told you about number 1, it's neither prime nor composite. Prime has to have exactly 2 factors. So the answer for B, the prime factors of 12 are 2 and 3. Now what it says is express, I want you to star number C because we're going to be doing number C a ton in this lesson. Express the number 12 as a product of prime factors. Okay, so product, first of all, means multiply. That's what product means. And how you're going to do this is I'm going to teach you something called a tree diagram. So what you're going to do is you're going to take the number that I give you, and they gave you the number 12. And you're going to make a tree diagram dividing this number 12. And you're always first off to the side going to write what the prime factors are. So remember prime factors were 2, 3, what are our prime numbers? 2, 3, 5, 7, 11, 13. What you do is you take this number 12 or whatever number I give you and you always try dividing it by the lowest prime first. So we always are going to divide it by 2 first. So 12 divided by 2 is 6. Then you go to the 6 and you keep dividing that by 2 until 2 no longer works. So 6 divided by 2 is 3. And you stop, your tree diagram stops when this number here is one of these prime numbers. So 3 is a prime number, so we stop. Then I tell students, circle all of this. And now we're going to write express number 12 as a product of the prime factors. 12 is equal to 2 times 2 times 3. 2 times 2 times 3. And if you want to put little times symbol, you can, or that little dot that I did indicates times. And if you checked on your calculator, 2 times 2 times 3. So let's clear this. 2 times 2 times 3. I just broke down 12 by a product of the prime factors. What I want you to do is we're going to do another one just to make sure that you are really good with this. Okay? So let's go to the bottom of this page. And they do 48. So the book shows a division table and they do a tree diagram differently. I really don't like how the book does their tree diagram. But let's do the number 48 together. Okay, so I want you guys to write the number 48 off to the side. So somewhere in your book, write the number 48. Write the prime factors. So we always start at 2. We never start at 1. 2, 3, 5, 7, 11, 13, 17. These are all prime numbers. You take the number 48 and you always divide it by the lowest prime first, which is 2. So if you have your calculators out, once these numbers get really big, it's often helpful to just type it in on your calculator. So 48, I always say divide by the lowest prime first, which is 2, and we get 24 as an answer. So 24 goes here. You then go to the 24 and you keep dividing it by 2. 24 divided by 2 is 12. Go to 12. 12 divided by 2 is 6. 6 divided by 2 is 3. I am done. The reason why my tree diagram is done is because this number here, the number 3, it's a factor, right? You want to get this last number to be a prime number, and it will be one of your numbers, one of your prime numbers listed. So I stop at 3. Then I tell my students, okay, circle all of your prime numbers and break down the number 48 and write it as a product of the primes. Product means multiply. So 2 times 2 times 2 times 2 times 3. Students, if they make a mistake on this, they'll make a mistake here. They'll forget to put this last prime number here. And then if you guys want to know you're right on a test, check. Let's type in our calculators 2 times 2 times 2 times 2 times 3, and we better get 48 as an answer. So 2 times 2 times 2 times 2 times 3. And we get 48. And that's how I know I did it correctly. Okay, what I want to also show you, this, how we work, this is called expanded form. Okay. The other way that we could write our answers is a different form that 2 times 2 times 2 times 2 to the power of 1, 2, 3, 4. There was 4 of them. 2 to the power of 4 times 3. That will give you your answer in the exact same answer. And so this is one way to write your answer in expanded form. This is the other way in power form, and I'm going to expect both forms on your test. So power form. Now, how do we check 2 to the power of 4 times 3 on our graphing calculators? So what you would do, hit 2. Right above your division is a hat, a little hat. That will go into your exponential. So 2 to the power of 4, we need to scroll out times 3, and we get 48. So all of those are equal to 48. Okay? Flip your page. Now, this says use a division table to determine the prime factorization. Again, I do the factor tree. So in your homework, anytime that it says a division table, you're just going to cross that out and write factor tree. I find students always get this right when they do a factor tree. Okay, so a big number this time, 2,772. Write your prime numbers off to the side. 2, 3, 5, 7, 11, 13. Take this number and you always divide it by the lowest prime, which is going to be 2. So we're going to use our calculators. Clear your calculator, type in the number 2772, divide that guy by 2, and we get 1386. Take 1386 now, divide that by 2, and we get 693. Now, if you try to divide 693 by 3, it will not work. So 690, or sorry, by 2. 693 divided by 2 will not work. So what we do in that case is you're going to scratch out 2, and you're going to go up to your next prime, and you're always going to check the next one. So now we're going to check 693 divided by 3. 231. Stay with your 3s until 3 no longer works. 77. Keep going. Let's check 77 divided by 3. Doesn't work. So now I got to go back up to 77. 3 is not divisible by 77, or 77 is not divisible by 3, so I scratch it out. I want you to check 5 on your calculator. Is 77 divisible by 5? And if you type it in, so I want you to type it in right now, you'll see that it's not divisible. So you scratch out 5. And then you're going to check the next number, 7. 77 divided by 7 is 11. And I stop because what you should see is what is special about this number 11. This is a prime number. It's going to be one of your listed numbers, and you always stop when this last number is a prime. So circle all those primes, write 2772, your given number, and let's write it as a product of the primes. That's prime factorization, you guys. Prime factorization means write it as a product of the primes. So 2 times 2 times 3 times 3 times 7 times 11. And you could check on your calculator. So let's clear this. I want to know that I'm right. 2 times 2 times 3 times 3 times 7 times 11. We are correct. Okay? And now let's write it again. Give our answer in, we did expanded form. Let's do our exponential form. So 2 to the power of 2 times 3 to the power of 2 times 7 times 11. and this is my answer. Okay, we're going to do one more. For this one, what I want to do, I'm actually going to write it on the next page because I'll run out of room. So 33250. So let's write that guy down. 33250. Let's write the prime numbers. So 2, 3, 5, 7, 11, 13, 17, 19, 23. Remember, memorize your primes up to at least 23. What I want you guys to do is I want you to pause this and I want you to see if you can do that. And then pause it and then you could restart the video, check my answer. Okay, so I'm going to work through it right now, but you guys, I want you to see if you could work through it separately. So 33250. I know that this number is not going to be divisible by 2, so I'm going to check 3 next. Some students want to jump to 5, but don't do that, right? Always check 3. If 3 doesn't work, then you could jump to 5. So 3 does not work. So I got to take that 16, 6, 25, and now I could jump up to 5. And I get 5 and 33, 25. So 3 didn't work. So now I'm going to continue with 5s until 5 no longer works. So that number divided by 5, 665. I know that that number is going to be divisible by 5. And I get 133. Now, 133, I know it's not going to be divisible by 5. You could check on your calculator, but 5 won't work. So I'm going to jump up to 7 and see what I get when I jump up to 7. And I get 19. Now, some of you will see this right away and some of you will not. If you guys get to 19, how many of you are able to recognize that that's a prime number? 19, and then the one after that would have been 23. If you got 19, if you got 23, those are all prime numbers. So I get a stop. My work is done. Circle all of those primes, including that guy. That's the one that students always forget for whatever reason, that last one. So 33250, writing this as a product of the primes, or what we're doing, what's called the prime factorization of this number, writing it as a product of the primes, would be 2 times 5 times 5 times 5 times 7 times 19. That's expanded form. 33250 in exponential form is 2 times 5 to the power of 3 times 7 times 19. If this was a test, I want you to type that into your calculator to make sure that you get 33,250, because the nice thing about this very first quiz that you guys are going to get, and one of these numbers will be on there, is you will hand in your test to me knowing if you got it right or wrong, right? Because if I put this in my calculator and 33,250 spits out, then I know I did this correctly, okay? I am going to give you your homework now, and then I will let you go do your homework. Okay, so your homework that I want you to do is number 1. So I always tell students to go ahead and circle in their workbooks what I want you to do. Number 2, I want you to do A, B, and E. Number 3, I want you to circle 6, 9, 10, 11 AC. So 6, circle 9. Now, use a division table. No, tree diagram. To determine the prime factorization of, I want you to do 10. It says use a tree diagram. Okay, we're good with that. 11, I want you to do A, and I want you to do C. And remember, next to all these questions, write your 11, 13, write your prime factors. Okay, so you do that for every single question. So 11 AC, I want you to do number 12. Which of the following is not a prime factor? So all of these are prime numbers, right? So these are all prime numbers. And you just have to divide um, all of these 1925 by all of these numbers, and one of them will not work. Okay, so do 19 or do 12, do 14. The sum of all of the prime factors. Okay, so this one maybe we'll do together. Sum is plus, so we're going to do this one together. And I might even actually do 16 with you. Let me just look at 16. Yeah, so let's do 14 and 16 together. And if you think you're good, you could pause the video and do your homework. If not, I'll do these two. One more thing I want to show you is make sure on the Google Classroom, so if you go to classwork, there's this workbook solutions. And if you open up the workbook solutions, what you're going to see is the complete, like worked out work. Now they remember do it slightly differently than I do. But if you have any trouble, like they have the work solutions in here. Okay, but let's do those last two questions together and then you guys are good. So this is a huge number, 373,065. So I'm going to write my prime factors, 2, 3, 5, 7, 11, 13, 17, 19. Okay, this number, I know it's not divisible by 2. 2 is not going to work. I'm going to cross it out. Try that number and divide it by 3. So 373,065. Let's check. 373,065 divided by 3. I get 124,355. 124,355. Let's check if that number is divisible by 3. And it's not. So I'm going to go back and I'm going to go get that number. And I know it's not divisible by 3 now, so let's try 5. I know it will be divisible by 5 because it ends in a 5. So divide that guy by 5, and I get 24,871. 24,871. Okay, I know that's not going to be divisible by 5, so I'm going to scratch that out. Let's jump up to 7. 3,553. Okay, let's try 7 again. So we always keep dividing until that like 7s no longer work. So now I could type in that 3553 and we're going to try our next number. So 7 doesn't work. Let's try 11. It works. So I get 11 and 323. Okay, 323. Let's try 11 again. So remember, you keep dividing until that number no longer works. Okay, so 11 doesn't work. So now I'm going to jump up to 13. So 323 divided by 13. Nope. Let's jump up to 17. So 323 divided by 17 is 19. And I hope you guys all see this. 19 is a prime number, right? So I get a stop. So I'm going to circle my primes. And 373,065. If I write that as a product of the primes, it would be 3 times 5 times 7 times 11 times 17 times 19. And what it says is what is the sum of all of its prime factors? So these are the prime factors and this is the product. But what this question is asking is what is the sum? Sum means you would add this together. And if you type on your calculator 3 plus 5 plus 7 plus 11 plus 17 plus 19, we should get 62 as your answer. Okay, so the answer for that would be 62. Let's do this guy. The number 686 can be expressed as a product of prime factors. Okay, so let's do that. Let's express this guy as a product of the prime factors. So 686, our primes are 2, 3, 5, 7, 11, 13, 19. Okay, so 686, let's divide it by 2 first. Clear this guy, 686 divided by 2, and I get 343. That 2 will not work. Let's jump up to 3. 343 divided by 3. Nope. 343. I know 5 won't work. So I'm going to scratch out that. I'm going to scratch out that. I'm going to check 7. 343 divided by 7 is 49. So 7 and 49. And you guys, if you take 49 and if you divide that by 7, 49 divided by 7 is 7. So 49 divided by 7 is 7, right? And you could double check, like type on your calculator 2 times 7 times 7 times 7 and see if we get 686. So 2 times 7 times 7 times 7. Yep. Okay, so let's write this. 686 is the same thing as 2 times 7 times 7 times 7. Now, so what the question says is the number 686 can be expressed as a product of prime factors in this form here. So what you need to see is this is not in expanded form. This is an exponential. So let's rewrite 686 in exponential form. 686 can be rewritten as 2 times 7 to the power of what? How many 7s are there? There's 3. So 2 times 7 to the power of 3. So look at this. P, so what would P be? P would be 2, Q would be 7, and R is the exponent. That would be 3. So now I figured out what P, Q, and R are. And now what they want me to do is, well, what is P plus Q plus R? So 2 plus 7 plus 3 is your answer. So I'll say 2 plus 7 plus 3. And my answer is 12. So P plus Q plus R is 12.